So, lecture 2, retaining wall. In continuation to our previous lecture, so now we will discuss another type of retaining wall, that is cantilever retaining wall. Now, see in the picture, there is a retaining wall which is looking just like a cantilever. In the bottom, there is a slab which is named as base slab, that is basically just like a footing having toe and heel portion, and in the above the vertical wall that is known as stem, and to connect the stem and the base slab, one key is inserted which will make the connection more efficient. Now this retaining wall is retaining the backfill that is shown behind the wall, and the above this level is the ground level and this is backfill, and to drain out the water if some water is available in the backfill or due to any fall, any connectivity of water, so that water will be drained out through this drainage. And in stem, if the height of the stem is greater, then we have to provide construction joints. On the toe side, if you see, there is a ground level, and this this ground level, this material, whatever is the type of material, it will be also applying some pressure, and backfill will also apply pressure. Now the cantilever retaining wall, as I already told, that it is composed of stem slab. This is stem slab, and this one is the base slab. This type of retaining wall may be made up of r.c.c, precast concrete, or pre-stressed concrete. And construction can take place at site, or some precasted components can be assembled at site. So that means precasting as well as casting situ, both type of construction is possible. It may be economically in comparison to gravity wall. You may be aware the gravity wall, all the stresses will be taken care by the weight of the gravity wall. So that's why size of the gravity wall is larger as compared to the cantilever retaining wall. Another important thing is, however, cantilever retaining wall have their own benefits, but the construction, during construction, efficient construction should take place. That means construction need to be cast carefully. So while designing a cantilever retaining wall, sliding failure, overturning failure, and bearing failure, all these type of failures we have to take into consideration. So pressure, whatever be the pressure acting on the wall, we have to take into consideration that the design of the wall should be such that it should be safe against sliding, overturning, or bearing into the soil. Now see the figure here. First one is sliding. That means wall. Earlier we have discussed wall can slide away, or it can overturn due to the movements, or it can penetrate into the soil, that is bear into the soil. So your retaining wall, when we design, we have to take into consideration all these type of failures, so that our structure, our cantilever retaining wall should be safe. Now another prominent type of retaining wall which we will discuss, that is counterfort retaining wall and buttress wall. Now you see the figure here. You will find there is a stem. It is just like a cantilever wall, similar to earlier wall. The cantilever portion is there. That means this is the stem. Now heel slab is there. Up to this it's okay. Now, retained earth will be on this side. So what will we observe if the retained earth, its pressure is more? That means then you have to, when you construct, when you design, then the length of wall and the height of wall will increase. And to compensate the pressure from the retained earth, what we can do, we can construct these inclined walls, just like wall Lego structure, which we call as counterfort. So particularly, it has its own benefits we will discuss. Now, higher bending moment carrying capacity by the counterfort. So these counterfort will compensate or take care of excessive bending moment. Otherwise, you have to increase the height of the wall. Again, it is composed of stem slab, base slab, and third component is counterfort. It's cantilever type, and counterfort walls will act as a strengthening component, that it will strengthen the stem slab. Counterfort spacing. Now, spacing between the counterforts will be decided as per the requirement. That means major benefit is this particular slab. Now, when you are putting counterforts, so that means what you are doing, you are decreasing the span of the slab. So that means you will be designing the slab. This slab will be designing in form of some panels. Another important thing is counterfort. These counterfort are embedded in backfill. That means they are constructed behind the wall. That means towards the retaining of the earth side. Counterfort divide the stem slab into smaller panels, as I already discussed. Now these type of walls are efficient and constructed when the height of the wall is in between 8 to 12 meters. So then they are more productive, more effective, as well as economical. Now another important wall is similar. It is just similar to this, similar to counterfort, but here we call them buttresses, not counterforts, because you will see here the buttresses are in front of the wall, not behind the wall, as in the case of counterfort. So they are just like counterforts, but the terminology used is buttresses. Now earth will be retained this side, this is stem, and they are in the front. Buttress wall is similar to counterfort retaining wall, but the support to the stem are in the front side, as already discussed. So buttresses connect the stem. Now what buttresses are doing? They are connecting the stem with the toe slab, but in this case counterfort connect the stem slab with the heel slab. So this is the basic difference between them. Buttresses are structurally more efficient than counterforts, but in general, counterfort walls provided. Why? Because counterforts are behind the wall, they are not visible. Aesthetically, this wall will look better as compared to this, because this is the front side, and front side, if you construct these type of buttresses, then they have their own disadvantage aesthetically as well. So it is better to provide counterfort walls wherever will possible, or if not possible, if the conditions are not such that, then you can provide the buttresses wall. Okay. So now another important aspect of the design is that why we are designing the retaining wall. So that means it has to retain various type of loads, and here we will, in this slide, we will discuss what are the various stability parameters of that means what we have to consider while designing the retaining wall, so that it should be stable. Now stability conditions. To make the retaining wall stable. Retaining wall must be structurally sound to resist the lateral pressure by backfill. Design should be such that it should be safe against sliding and overturning, as we have already discussed. Now, combined stresses due to all type of forces and loads should be lesser than the safe bearing capacity of the soil. Otherwise, it will not be possible to get the stable retaining wall. To prevent the accumulation of water behind the retaining wall, backfill should be suitably drained by providing V-poles, as we have already seen. Longer retaining walls must be provided with expansion joints, we have already discussed, at suitable sections. Now, what are the various type of loads which have the possibility to act when designing the retaining wall? Self-weight of the retained wall need to be considered by the designer. Undoubtedly, in case of gravity retaining wall, self-weight is the most prominent factor, or one of the most prominent factor. Second, vertical earth pressure. Now you have seen in the diagram that some of the earth is on toe side and other is on heel side. So we have to take into consideration all the vertical loads on the toe or as well as on heel. Then third point is lateral earth pressure. Now lateral earth pressure may be active earth pressure, passive earth pressure, or at rest condition. So we have to take into consideration lateral earth pressure while we design a retaining wall. Vertical and horizontal live load, which may be due to surcharge or any reason, they need to be incorporated in the design. Horizontal water pressure. If there is water, that means if the soil behind the retaining wall is saturated or depending on the condition of the soil, you have to take into consideration the water pressure. Vertical uplift pressure due to water table, if any. So, whatever be the type of loads can act there and the possibility of the loads, you have to take into consideration effectively to make your structure stable. So, in next lecture, that lecture 3, we will discuss about the design of retaining walls